Okay, section 6.5, completing the square is its title. We want to be able to continue working with these quadratic equations, but we've traveled from what we called vertex form to standard form, and now it's time to go the other way, which is slightly harder, but we'll work you through it today. Transform quadratic equations from standard form to vertex form. So notice, if I would ask again, are these two equations equivalent, you wouldn't be able to tell face value. You could do a couple things, like you could compare the graphs. You do know that vertex form to standard is nothing more than our algebra. So again, real briefly here, our algebra would look like this. Y equals 3. We would do square the first, take the product of the two doubled, square the last. We would triple everybody inside, 3x squared plus 6x plus 3, and then subtract 4. So our final answer, 3x squared plus 6x minus 1. And then we can compare that to the other equation. They are both considered to be in standard form, and we can say, yes, they are equivalent, without even having a calculator and needing to graph. But we want to be able to go the other directions. So our quadratics have come in two forms. Vertex form, again, remember HK here is the new vertex. The movement that your original parabola, which was at 0, 0, took to get to its new location might be here at HK. The A value is the width of the parabola. It also determines if the parabola opens up or down. And then standard form, we like to say y equals ax squared plus bx plus c. So our goal today is going to be going from standard to vertex. Now we just did that. We did one like that. Remember, you have to, going from vertex to standard, you have to do that, completing the binomial square, distribute, move any terms over you need to, complete with adding and subtracting, so that when you finish, your equation is in the form y equals ax squared plus bx, your middle term, plus c. All right, so let's go for the harder one, and that is, try to remember, when we talked about completing the square, our binomial square theorem, to convert from standard form to vertex form, a process known as completing the square is used. In our binomial square, we had the rule that said square the first, take the product of the two terms and double it to get the middle term, and then square the last. All right? So that is key. If you haven't been using that shortcut, now it's time to bring it into play, and it will be very beneficial to those of you who have. So x squared plus bx plus what? So if I have a first term and a last term, the question is, what goes here? Well, remember, you doubled the product of the two terms. So if you doubled it, you have to undo that when you go backwards. You can't be working with that middle term's doubled action because we need just the h in order to get an h squared value. So if we do that on this, and we have an 8x, so I'm saying, what's the guy that's going to make that? So start thinking, well, 8 is our doubled term, so if we undid that, we'd have a 4. If we then squared that, we would have our last term. So if that middle term is considered to be b, we took half of the middle term. You can either say divide by 2, or you could say half of b. And then what did we do? We squared it. That's how we got back to that original. So once we had that h value, we then could get back to where we started. Because we knew that x was a 1 when this is a leading coefficient of 1. So that's the key piece, leading coefficient of 1. So let's start on this one. Do we have a leading coefficient of 1? Yes. So find your middle term, take half of it, square it. What do you get? Should be a 1. Next one. Find is your coefficient 1? Leading coefficient? Yes. Find your middle term, 30. Half of it, squared. That's the process you're going through. If you can't do that in your head, use your calculator. But we do need those values. So if we would rewrite either of these, which I didn't yet, and we wrote it back as a binomial squared now, and you know what that term is, you should be able to write the quantity squared. So if I had an x squared minus 2x plus 1 that was my perfect square trinomial, you should be able to go backwards and say, well, that is x minus 1, the quantity squared. In the green, it would be x plus 15. Down here, so x squared plus 7x. So now this is the first one I didn't give you a nice even number on. So what? The process is the same. Take half the middle term, 7 halves. Don't give me 3.5 because you won't recognize it. So 7 halves, 7 over 2, and square it. When you square that, you are going to get two perfect square numbers. It might be a fraction like this one is, and it might not. But whatever it is, you're going to recognize the 49 over 4 as perfect square numbers compared to, what is that, 12.25. You're not going to recognize that decimal. So then you come back over here and say, okay, what do I write? Well, you know the first term is an x. Now look at your fraction. What's the square root of that? And you can do that much quicker. Square root of 49 is 7. The square root of 4 is 2. And you can write your binomial square right from your trinomial. So to complete the square, moral of the story, you should be taking half that middle term and squaring it. That process is going to be huge in our work as we move forward here. All right, moving forward. Take down these steps, and then we'll show you what they look like in an example here that we do. I will just write them as I go and do the steps, talk through them, so you'll have time to write your steps down, or you could pause it and write your steps first. All right, start with the standard form equation. We have one, ax squared plus bx plus c. We have it. Divide all your terms by the leading coefficient if it does not equal 1. Well, we have a leading coefficient that is a 1, so therefore we don't have to do that division step. Use the additive inverse to move that constant term to the other side, because this constant is not a perfect square number. It needs to be moved to the other side. So we are going to do y plus 90 in moving it. That'll still leave us on x squared plus 18x on the right-hand side. Then it says add a blank to both sides. What we mean is a fill in the blank, something you can add. And remember, in our balance, if we add something on the left in algebra, you must add it on the right. So you can't just add it to one side at a time. So we get a blank on both sides. Now here is where we do our completing the square. Take half of the middle term. Well, our middle term is an 18. Half of that is 9. Square it is an 81. That squared value, step 6, is added to both sides of the equation in the blank. It is the new missing piece. It is that number that completes the square. And if we have an 81 that completes the square, that now means on step 7 that on the right-hand side we can now factor and make that a perfect square trinomial. By doing that, we'd have our x. The square root of 81 is 9. Everything is plus sign, so we'd have x plus 9 quantity squared. Add like terms from the other side. That would be the two numbers, the 90 and the 81. Give us 171. We want it in y plus 171. And so now make sure that it is in vertex form. And if you remember, it mirrors vertex form now because our vertex form said y minus k equals a times the quantity x minus h, that quantity squared. And you can see that our vertex is now -9, -171. So this was a fairly large move. It got moved 9 to the left and down 171. That a value should still be a 1 because it was a 1 back here. So it does fit vertex form. And that final equation is your equation that is in vertex form. It has to match the setup exactly. All right. So using those steps now, we got one more example here. And that is, what if that a term is not a 1? And here's a good example. It's not. So step 1 says divide through by that a term so that we would have a 1. It's going to give some fractions into your work, but that's okay. So with those fractions, we now have on the left-hand side y over 3 equals simplified x squared minus 4x plus 1/3. But that 1/3 is going to get moved anyway, so let's just move it over to the other side with a subtract 1/3. Okay? So now this is a step where we now can add our blank to both sides and start working on what is that number that would complete the square. Again, find your middle term, -4, take half of it, -2, square it, would be a 4. So we now need a 4 to be filled into the blank. Half the middle term squared. You just made that right-hand side a perfect square, so write it as a perfect square binomial. The square roots are the easiest ways, and then your sign has to be the sign that's between your first and second term, so it has to be a minus. And if you would FOIL this back out, it surely would make x squared minus 4x plus 4. On the left-hand side, look what you have. And here's where the two are slightly different. The one where you had a first term that was a 1 and now we don't. Remember, we put that 3 over there by doing a divide by 3. Well, eventually we have to move it back. So I believe at this step right here is a good time to do that. We're going to move that divide by 3 back over. But in order to do it, we have to times each of our terms on both sides by 3. And so on this side, instead of doing each term, we're just going to put it out in front. Of course, if we would multiply that out, it would get multiplied. All right, so now what's left? Well, 4 times 3 is 12. The 3's cancel here, and we have a -1. And then the 3's cancel here, and we have our y. So finish putting in completely vertex form. Clean it up. Our y should lead off. 12 plus a -1 is 11. Equals 3 times the quantity x minus 2, that quantity squared. So again, we can say our vertex is at +2, -11, if anybody asks. One more like that, I believe. Solve by completing the square. This one might get a little messy, but again, it does not have an a term of 1, so let's work through it. I don't think there's going to be too many differences, but this one, the difference is solve by completing the square. They want you to solve for x. So I don't have a y equals on this one. So watch as we go through this, and we'll be able to solve when we're finished, obviously. So we have that x squared plus 18x plus 12. If we're going to be solving, we want everything to be 0. So we're going to go 0 equals 6x squared plus 18x plus 12. Now, again, we need to divide by 6 first because we do not have an a term of 1. That'll give us our a term of 1. So divide every term by 6. When we do that, 0 equals x squared plus 3x plus 2. Next step. It's that 2 that needs to be moved to the other side. It is not a perfect square number, so it will be. And when we bring the 0 or the 2 over, it'll come over as a subtract 2. So 0 take away 2 is -2. That'll leave an x squared plus 3x. And then now we knew our blanks, so we can complete the square. Half the middle term, there's an odd number here this time. Half the middle term is 3/2. Squared is 9/4. So that number that's going to go in to complete the square will be the fraction 9/4. All right, with that, we now have room to make our right-hand side a perfect square binomial. The square root of the first is x. The square root of the last term is 3/2. The sign we want to take is everything's plus, so a plus. On the left-hand side, we now have 9/4 plus -2. Now remember, 9/4, or you can say the -2 is the same as 8/4. but it's a negative 8/4. Negative 8/4 added to 9/4 will leave us with 1/4. All right, this was a solve problem. So when it says solve, that still means get x by itself. So if I'm solving to get x by itself, I now have to undo this parentheses. Well, I can't do that until I get rid of the squared. How do you undo a square? Most of you know, with a square root. So we will take a square root of both sides. And when you take a square root of a square, you get 2 solutions. On this side, the square root of a square leaves us just what's underneath. Over here, remember, this is a perfect square number. So what's the square root of 1? 1. What's the square root of 4? 2. So we have a plus or minus 2. All we need now is to get x by itself, so we'll move that 3/2 over with a negative 3/2. If we have negative 3/2 plus or minus 1/2, we're going to get 2 solutions. So here we go. If you have negative 3/2 and you add 1/2 to it, you're at negative 2/2. Negative 2/2 is the same as negative 1. The other solution, negative 3/2 minus 1/2, is negative 4/2. Negative 4/2 is negative 2. So we get 2 solutions. We write the fractions in lowest terms, and so we have solved by completing the square in the process. The difference was we didn't have the 0. We weren't writing it in vertex form. We allowed the right-hand side to be square rooted to help us get x by itself. So keep those 2 things in mind. Look at them again, and we could do 1 or 2 or answer some questions about the process in class. All right, that's all for now.